Your phone is catching an invisible radio wave right now. Not a tiny wire, not magic, and not the internet floating like soup. A box in your home is throwing patterned waves through the room, and your phone is decoding them fast enough to make a video feel instant. Wi-Fi does not send a website whole. It breaks requests into packets, rides them on radio waves, waits for tiny replies, and rebuilds the answer on your screen. Miss one piece, and the whole trick starts to stutter. Once you see the path, bad Wi-Fi stops feeling random. The dead corner, the buffering, the password, even the router shelf all start to make sense. So follow one message from your thumb to the internet and back. First, Wi-Fi is not the internet. It is the bridge to the internet. Your tap starts as simple digital instructions inside the phone. The phone is not asking the air for a video. It is asking the router to carry a request towards servers far away, like handing a note to the one person who knows the hallway. The router is a translator. On one side, cable or fiber brings data from your internet provider. On the other side, antennas turn that data into radio patterns your phone can hear across the room. Radio waves are part of the same big family as light. Your eyes cannot see Wi-Fi, but your phone can measure it. If visible light is a flashlight, Wi-Fi is a flashlight with ink only electronics can read. The wave does not carry a miniature web page. It carries changes, stronger, weaker, shifted, timed. Those changes are a code. Your phone watches the wiggles and turns them back into bits. Because the wave spreads, location matters. Close to the router, the pattern is crisp. Around a corner, it arrives faint, bounced, and late, like hearing music through an apartment wall. That is why bars are not a speedometer. Bars mostly say how clearly your phone hears the router. A strong signal can still be slow, and a weak signal can still work if the conversation stays clean. Now the fun part, how bits actually ride a wave. When you open a page, the phone slices the request into packets. Each packet carries a little payload plus labels saying where it came from, where it is going, and how to put the pieces back in order. The router does not shout every packet blindly. It uses a carrier wave, then changes that wave in careful patterns, a bit like tapping a pencil in code instead of mailing the whole pencil. Modern Wi-Fi can pack many bits into one tiny wiggle when the signal is clean. When the room gets noisy, it uses simpler wiggles. Less fancy, more reliable, like packing a suitcase after the zipper starts judging you. Your phone and router keep checking if packets arrived. A tiny acknowledgement says, "Got it." If the answer is missing, the packet is sent again, so a video call may freeze before it fully breaks. The air is shared, so devices take turns. Laptop, tablet, speaker, doorbell, phone. Each waits for a quiet moment before talking. It is polite, but a crowded room can make politeness feel painfully slow. The router also decides where to send things next. Local traffic stays inside the house. Internet traffic goes out through the modem, into your provider, and then across a chain of networks toward the server. Before the data party starts, your phone has to get in. Before data flows, the router announces itself with little beacon messages. Your phone scans, recognizes the network name, and says, "I know that one. It is less romance, more clipboard." Then comes the handshake. The phone proves it knows the password without simply yelling the secret into the room. The router and phone agree on keys like a bouncer checking a list before opening the door. After that, every frame is wrapped. Someone nearby can still sense radio energy in the air, but without the right keys, the useful message looks scrambled, not readable. Your phone is not connected to the whole internet by itself. It is connected to one access point first. That access point becomes the local doorway for all the farther places you visit. If you walk around, the phone constantly judges signal quality. It may cling to the old router too long, or jump to a mesh node nearby. Roaming is helpful, but it is not mind-reading. This is why moving one step can change everything. Your body, a fridge, a mirror, or a wall can block or reflect the wave. The phone is always solving a tiny moving maze. So why does one room have perfect Wi-Fi and the next room suffer? Walls do not hate Wi-Fi. They just absorb and scatter some energy. Drywall is usually gentle. Brick, concrete, metal, mirrors, and water are tougher. A fish tank can be a very pretty signal sponge. Lower frequencies travel farther and bend around obstacles better. Higher frequencies can carry more data, but fade sooner. That is the trade: long reach versus big highway. 2.4 gigahertz is the patient walker. 5 and 6 gigahertz are faster sprinters with shorter breath. Put the router behind a cabinet, and even the sprinter starts wheezing. Reflections can help or hurt. A wave may bounce off a wall and arrive by a second path. Sometimes the copies add up. Sometimes they step on each other and make a quiet spot. Interference is simply another pattern in the same neighborhood. Neighbor routers, old devices, baby monitors, and microwave ovens can crowd the channel, especially when everyone picks the same lane. The router tries to avoid chaos by choosing channels and steering devices. But if the room is packed, everyone still shares airtime, like a coffee shop where every laptop wants the only outlet. Distance is not the only villain. A bad cable, an overloaded modem, an old router chip, or a slow internet plan can make perfect bars feel useless. The radio part is only one leg of the trip. Now the mystery every house knows. Why does it buffer? When a video buffers, the failure might be anywhere. The phone may have missed packets, the router may be busy, the provider may be congested, or the server may be slow on the other side of the planet. Speed tests hide this complexity behind one number. Download speed is how much can move. Latency is how quickly the first answer comes back. For games and calls, latency is the tiny thorn. Wi-Fi also uses retries. If a packet arrives damaged, it is sent again. One retry is invisible. Many retries turn smooth video into stop-start motion, like a browser with too many tabs trying to remember its name. More devices do not just consume speed, they consume talking time. A security camera, a speaker, and a laptop all take turns. The slowest talker can make the whole conversation wait. Your router is a little computer. It has memory, a processor, radios, and software. When it overheats, gets old, or handles too many jobs, the neat radio dance becomes a tired shuffle. That is why rebooting sometimes helps. It clears stuck software, refreshes connections, and forces a new start. It is not magic. It is the router taking a tiny nap and waking up less confused. So how do you fix Wi-Fi without superstition? First, raise the router into open air. Not under a desk, not inside a cabinet, and not behind the television's metal shadow. Radio wants room more than it wants a fancy hiding place. Next, separate jobs. Use the lower band for reach and simple devices. Use the higher band for nearby phones, laptops, and streaming. If your gear supports 6 gigahertz, keep it for short, clean, fast links. For bigger homes, mesh nodes can help, but only if each node still hears the main network well. A mesh node placed in a dead zone can only repeat the sadness. Cables still matter. For a console, desktop, or work dock, Ethernet is boring in the best way. It skips the shared air completely and leaves more radio time for the devices that must roam. The real picture is simple. Wi-Fi is a local radio conversation, the internet is the faraway road, and your router is the translator at the door. Fix the conversation first, then blame the road. Next time your phone buffers, do not just glare at the bars. Move the router, clear the path, split the bands, and remember, the internet did not vanish. The wave got messy. Subscribe and like for more.